Hello, everyone. And we want to introduce you to Harbor for creating benchmarks. And just first, we start. It's like about benchmarks. Now it's a typo, so you can see it was not Vibe created, but manually created by my own hand, with typos there. Then there'll be the introduction. What's Harbor as a framework, technical one. We'll try to run it. So hopefully, if you have a computer, you can also open it. You can give it a try. Otherwise, we can also show it on this display. And if you have time and energy, you will be able to create your own benchmark. But before we start, I invite you to open the link for a very short survey. So there are no good and bad answers. So it's like there's no any score. As you can see, if it's how it works. Okay, so like yeah. I'm just curious, like when it goes to the other, like what are the other models you like? No, just concrete ones, like just Bielik, okay, Bielik one, and which else? What? Perplexity, okay. So Kimi is I think there, but no, it's like Gemini, okay. So yes, like here, like this distribution, I guess it also depends on the task. And I guess like the next one will be different and the next one will be different, right? Because everything changes. And a similar thing, so when it comes to if you use any AI-assisted editor or a CLI tool, so like which one use, so you can actually select more than one. Or like if you, use only code by hand or don't code at all or stuff, then just you can say also nothing. Okay, so also there's some healthy distribution.
There's no other here.
Well, oh yeah, so you can say which one?
Open code.
Open code, yeah, nice. Which other as well? No, just Gemini CLI. Nice. Okay, so a few more responses. Nice. And the last question, have you ever benchmarked any AI model agent? I'm not mentioning even like writing like a full benchmark, academic or industrial, but even like testing. So just you have a script, you test, for example, if this model works for your problem. Nope, okay. Oh, actually there's like, a few like people already done it. So it's like, I'm just curious, like for those who actually created some things, did you use any framework or like just scripts? Like how did you, okay, so what did you do?
Yeah, so basically it had like a schema of like what I wanted to extract from tests.
Mm-hmm.
So I just verified like kind of manually to make sure over like 20 test cases that it produced the results I wanted.
Mm-hmm. So like it's manually checking, like basically examples like make sense, basically. So this is in most cases necessary because we never know if it's great at this job or basically generates something very random. And this thing is like actually it's necessary not only if you create models, but also for any task. Because, well, we have no idea if a small prompt change or data change is going to ruin our results. And now like we want to show you a thing about benchmarks and actually how to use this part. This part, so like how to create a benchmark for agents. And if you like want to participate, like actually use your computer to run some of the tasks, there's also a technical question, or maybe a reminder. What do you have on your computer already? This like Docker is like Docker, like a container for stuff. UV is like basically the new and the best Python package manager and runner and stuff. Harbor is what we are talking about. The good part is that you can install in one line with UV. And LLM API keys, well, if you have one, it's great. If you don't, we'll distribute. So just don't eat all, because it's super easy to eat all tokens in just a few minutes. But yes, it's actually very nice. So let's go back to the main part. So when it comes to, there's a new model, usually what I see, like, I look at benchmarks. So not only to see at claims of various laboratories, which always says is the best model, but here, for example, it's LM Arena, when people compare various models. So they just make a judgment if something's nicer or better. And for various things, like, for example, image to text, like text to image is the best because it's some kind of subjective claim. What's the better quality, how it works. Also, like, if there's a new model release, all the time we see a lot of charts, basically telling if a model is better than the others. Usually it is better, at least according to charts they share. And here, like, it is one TerminalBench, which be over with us all the time, because the TerminalBench is created by the same creators that created Harbor, based on the experiences with creating previous, TerminalBench 1 and 2. And also, like, there are quite a few other benchmarks about knowledge, about agent encoding, about other things. But usually, at least right now, this TerminalBench is some kind of golden standard for software development. Not all like models say that, oh, just we are the best. Some are slightly more humble, especially open source models that say, oh, just actually we are open source, but we are almost as good as the free-entry models. In the sense, I think it was released yesterday, literally, GLM5, that say, oh, just we are open source, but still almost as good as the best models on the market. Still, as you see, like, TerminalBench is one of those benchmarks they use. And except for benchmarks which are basically showing charts, so it's here's a kind of irony, because this chart shows that GPT 5.3 codex is better than Cloud Opus 4.6. At the same time, someone said that they vibe coded it in Opus. But it's like this a very, very, fierce competition. At the same time, and of course, it depends also on the use case. But also there are other benchmarks, also subjective ones. I don't know if you saw this one. Basically drawing, using SVG, so not a text, not image, but SVG, to draw a pelican riding a bicycle. And only recently, models started to get the idea. And when it comes to the TerminalBench, it's like, because it's not only we measure LLMs, so database models, but also agents. Because depending which agent you use, sometimes results can be better or worse. And here we can test for both. For example, like, is Cursor better or Cloud Code? Or is it than Codex, even for the same model? And in this, like, Harbor basically solved the problem of how to create a benchmark. Because, sure, you can write your own scripts, and it's fine. And we have done that. But it's much better when you already have a framework for creating benchmarks, some kind of structure, and also a way to run it in an easy way. It's important for you because you don't waste time creating your own scripts, but also for others, so they can easily run your scripts. Before that, basically, everyone wrote their own stuff, and it was, like, much harder to run it. Also, we did also first run our own stuff for CompileBench, but then the next two benchmarks we created were already Harbor, and then also we migrated previous ones, CompileBench to Harbor, because basically it was easier for us for others to run and also to test other models. And before, like, we follow, it's like there are two things, like, if you have a computer, like, two things to have. One is repository with code you can run, and the other is API key. Here, like, it's open router API key, so that it's easy to use models from various providers. And I'll be, like, around in this room, very happy to help you. And now giving my voice to Przemek.
Hi. it readable, all of you? I kind of think it is, or should be, at least. Cool. Okay, so I am basically going to walk through the anatomy of a Harbor task. So how does it look and what each piece of a task definition is responsible for. So basically, a Harbor task is a directory. The convention here being that the task name is also the directory name in which you have all these task files. Also, if you ever clone publicly available benchmark, you are going to find a lot of boilerplate, because within Harbor there's no templating engine or anything alike. So each task essentially has a lot of these files just repeated. But that's just the current state of the project. So I'm going to walk through all of these files here. First one being the task.toml. Essentially, this is a task metadata. You can put any fields you want here and group them. Here we have things like author name, but also maybe some tags or labels for your tasks, but also some properties which might be required for specific runtimes, such as CPU limits or timeout you want to have on your agents executing your tasks. The next thing is the instruction.md. So with Harbor, you are required to provide this specific file which contains the actual instruction for the agent, so the actual assignment for this task. In this case, we are simply calling the agent to just compile a Golang program. Yeah, and it's all in Markdown file, so there's no problems with like having that definitions in your Python code and worrying about formatting that much. By default, Harbor's execution harness is based on your local running Docker containers. So we specify our environment in such form that we have a Docker file, which essentially builds the container image, and the task is running in that container. Additionally, in case your task requires any other files, then you also put them in this directory, maybe source code or anything that needs to be accomplished anything that needs to be there for the task to be accomplished. There's a chance that you might also require a more complex environment. So if you would like to bring up even more containers within task or enforce network isolation, you can do it by placing Docker Compose in this directory. So the next thing is test. Harbor framework requires you to include a test.sh script, which essentially runs a test scripts. Once agent claims that the task is finished, Harbor is going to run a test suite. So this is like an entry point for your tasks, for your tests. You can use, from here, you can basically use any testing tool you want to use. I will be using PyTest in my examples later on. After the task is finished, the whole test directory is being copied to the container, and then this script is called. The expectations from the framework is that the test.sh script is going to produce a reward file, which will contain task grading and the actual results. So as you can see here, like these all elements are very sort of loose, and there's not much. There's a structure to it, but it's a lot of flexibility and a lot of room for anything that you might want to put there. This is completely optional element for each task, but pay attention that whenever you would like to write a task for publicly available benchmark, typically you will be required to also provide a solution to your task. So the expectation here is that once Harbor spins up the environment, solve.sh script is being copied, and it should essentially bring the container to the state where all the tests pass. And I will also going to show how it looks in my example. So yeah, let's right now I'm going to show you our example task. We are going to run it and see how it works. But first I will actually walk through this example task again one by one and tell you what do we have here. So of course we have our metadata file, just author name, email, and some environments properties. Brief description as well. So this example task is simply to compile a Go program which lives in the app directory. We have some specific requirements, like we want the executable. Yeah, hold on. Maybe I can use the presentation mode. Yeah. Okay, this is going to be much better. Okay, so we have our task instruction. So basically, compiled executable needs to run successfully. Let's move to the environment. Environment is just a simple Docker container, Ubuntu-based image. We install a Golang compiler. We, of course, copy our source file, which is here. It's just the simplest Go program you can imagine. Our solution is just to change directory and go build main.go file. It's not that sophisticated. And the test.sh script. So in this case, I want to show you something more complex. We are basically using PyTest tests, and which are defined in a separate file. We install all the required test dependencies, and at the end, depending on the PyTest exit code, we produce a reward file with the task grading. Here we go for just a 0 or 1, but you can use float numbers as well. You can also create a reward.json file and have more, in case you want more complex grading, like step-by-step grading of a specific task. And with regards to the test itself, I chose Python because it's just way cleaner and way more convenient than pure bash. So simple assertion that the binary exists, it's executable, and that's it. So, okay, so I have my open router key exported here, and now I'm going to run it. I'm actually going to quit the presentation mode for now. Okay, so right now I will run this example task. As you can see here, I'm just passing the path to the task. Task is running right now, and what you also may notice is that there's a new directory here called jobs. This directory contains all the necessary data about the task run. So you can see all the agent logs, the trial log. Soon we are going to see specific agent steps that are being taken. And in the meantime, we can also run this harbor view. We just need to pass as an argument, we just need to pass the path to the jobs file. So as you can see here, okay, right now we have some agent trajectories. There's a prompt and all the data that essentially captures what agent has executed. By the way, this whole format is also part of the Harbor framework. This is actually called the agent trajectory interchange format. This is also a thing that the guys at Lauda Institute, so the Harbor creators, wanted to standardize. And it's open standard. There's RFC for it. So as you can see, it's constantly being updated recently for the multimodal trajectories. But in order to see how it works, we can actually use the UI, and it looks like following. We have our job. We go and see our example task. And here we have our agent performing our tasks. So basically, we can preview step by step what happened and what the reasoning was. You can see all these command executions here, and also the command execution output, how much time it took. And also there's a log from the verifier, so you can also see that all the tests has been successfully executed and passed. So one note about the agent. So I used the Terminus2 agent and just passed the model name. This Terminus2 is just a default LLM agent used within Harbor framework. Of course, there are different agents. This one is actually quite nice because it reaches to LLM API via Light LLM library. So you can just specify pretty much all the models that you would like, either via Open Router or just directly with specific providers API. And it has all these basic tasks that you need for the task to be accomplished, such as executing bash commands, etc. Of course, you can use a different agent. You can use Cloud Code. Just remember that you need to specify Anthropic API key separately because it just won't execute the Cloud Code like directly. That's just the way this agent is implemented. There's also Codex, Gemini, CLI. There's a bunch of different agents here available. And one special agent here is the agent called Oracle. As I've said you before, there's this solution for each task, so solve.sh script. Essentially what agent Oracle is doing here is that it's just creating this environment, and once environment is being created, it copies the solution script and just executes the solve.sh. So therefore you can see if your solution is also working and if it's providing you the same reward as your normal agentic run would. Okay, we can see the preview right now. So there's a separate run here. And you can see that essentially also all the tasks have passed right now. In case you would like to run agentic tasks at scale, your local Docker might just not be enough. If you would like to run, let's say, 15 tasks and 10 trials each, then you would basically burn your machine. So you can use a remote environment such as Daytona, which is one supported by Harbor creators as well. You just need to set up a Daytona API key. So if you were to create your own tasks, I would highly recommend checking out the TerminalBench repository. Right now, having this knowledge that you have, you can simply go to each task and investigate it on your own. And you see that the Harbor format is here. We have our instruction. We have solutions for all the TerminalBench tasks. So you can right now contribute to publicly available benchmarks as well. And we also would like to encourage you to check out our benchmarks. So they are also publicly available on GitHub. Our first one has been CompileBench, which focuses on compilation of software with various difficulties, like we force agents to use static linking or use some obscure compilers. We also have AutoBench, which focuses on how good LLM agents are with instrumenting the existing software with OpenTelemetry. And this week we have also released a binary audit which checks how good agents are with investigating backdoors or any malicious code in the binaries. So also within this repository, which is here on GitHub, we have few task ideas for you that you can run on your own and just mess around with the example tasks. And Piotr, you want to also say a few words about the existing tasks, so go ahead.
So again, in this repository there are a few other problems, so you can see how it's constructed and to give some insight into those capabilities. For example, there's like one cipher. Just I know how to make it larger. Okay, but in which basically there is instruction that we have some kind of encrypted message. But at the same time, I have no idea how it is like this. Python works.
What do you want to use?
Yeah, there's and like there's like some encrypted message here, and we can decrypt that. And at the same time, there's another totally different task, which is free-body problem, in which we have to basically create a simulation, which is like very precise at simulating a free body problem in physics. So you have three planets rotating around each other, and can it create a program that not only works, but also is very precise. And also you can run those tasks the same way, with those instructions in the repository, and just to see if those models work. And if you still want to have API keys, so just, I don't know, if you want to give it a try, I can show you like this link with API key. And we are very happy just to assist you with setuping, with giving feedback, and answering any questions about how it works. So now it's like this is kind of hands-on part, and we invite you allowed to any questions. But before like this part is like that. Do you have any general questions about benchmarks or Harbor in specific? Sure.
Yeah, I have a question about the verification. You have mentioned that you support like binary pass-fail type of verification. Do you have some extension for like complex business logic verification? What I mean by that, check if the agent trace on step 6 has made the right conclusion based on information it received on step 5, right?
So, okay, this is interesting, actually.
Yeah, so within Harbor, you can essentially the framework give you very simple tool because you can write your results here. And as I've mentioned before, what you can do is that you can write a reward.json file, and from here you can essentially create a JSON file with specific results. What framework actually enforces you to have is that this JSON have to be in this structure with like flat, let's say. So you cannot actually nest this JSON file. You can only have key value pairs with specific results, but how these are filled is entirely up to you and the test.sh script. So you can even make this one just concatenating JSON or just building a hash map and just serializing it to a file at the end in this form of reward JSON. But the thing is that this whole verification always has to run at the end of the agent. So like you have to run task, agent has to claim that either timeout or claim that, okay, I'm done with the task. And then like the tests are going to run and the reward file is going to be produced. Like there is no possibility to monitor the reward once the task is still running. That's also one of your concerns.
Yeah, okay, thanks.
One thing is benchmarks. Second is reinforcement learning. Does Harbor like also have an extension or something that can be used for reinforcement learning?
Well, it's being used for trajectories in that sense.
Mm-hmm.
But in that so it's one of the core use cases because right now it's not only about training on data. So it's not about so this whole agentic framework is not about questions and answers because it's much easier to do so, but about giving problems and then getting trajectories and then learning from those trajectories. So this trajectory is this kind of chat of a agent with the system.
Great. And I imagine that because you can essentially put whatever you want in the value, then the number of steps, etc., to finish a certain task is also like you can set whatever you want, just and later use this framework.
Yes. So in general, it's like one thing is like it's the reward you give, right? And it's like can be binary, can be different, and you can. The other part is which test you write. So what do you test? There's even more different thing, which things you give to the agent, because it's up to you. Which tools you give, what do you install, are there any limitations? And the fourth part is when it comes to results, very often you want something also from those logs, and you have those logs. So you can see, for example, which trajectories are the fastest ones. And only during all, with basically all benchmarks we do, there's something like that, I don't know, just let's say benchmark. It's not only about results, of course, but about also quite a few other things. For example, how much does it cost, right? Because one thing is that if it's able to accomplish something, it's fine, but sometimes it's way too expensive. Or maybe also the same part with number of steps it's time it takes to finish a task.
Good. Thanks.
Other questions?
So,
Thank you.
yeah. Sure.
More or less, how much this example benchmark costed you?
Oh, just so for example, like here, this example, you can see that a single model, for example, like this was the most expensive one, is almost $300 for running something like 20-something tasks. And it was single run because of course you had a few runs before that, before we polish task and see how it works. And this is for a single one. And so, but there's not a direct question because it depends highly both on the models you use. So some are much more expensive than the others. The number of tasks you use, number of models you use in general, but also how many steps does it take. So for example, like in those kind of issues, it's not usually not the case that you get a few steps and you get the answer. It's expensive. Very often like this, 50 steps or like 100 steps before you get the answer. For example, in this CompileBench, if the task was very challenging, it was like trying things like, oh, let's try the one thing, it doesn't work, I'll try something different. And well, based on this multi-step process, well, basically takes time and money.
Plus, you definitely want to run your task like at least few times, like at least 3 times.
Yes.
Stochastic nature, so you also like have to multiply this cost by the number of attempts, which is usually at least 3 of them.
Like,
But if you want like a single number, the single run of TerminalBench costs like a $500 in over $500 in LLM tokens alone, and the binary audit is almost like a little bit less than $2,000 for a single run of this benchmark.
Do they give you tokens? Do they give you tokens, or you spend your own money to run it?
Unfortunately, sometimes we have to spend our own money for that.
Okay.
yeah, so this actually it was this benchmark got quite popular on X, or like it was still called Twitter before, and it was asking people as why on the most expensive settings. Said, okay, like fine, we are very happy to do so, just give us tokens. Because, for example, like if there are various benchmarks, like then sometimes it's fine that there's like one of models that got on the top, like it's me too. It's one of benchmark like for very complicated tasks, but sometimes the cost is basically very high. I think here like even not the highest one, but basically something which is there are orders of magnitude of difference how much you can spend on a single task. Almost always, if you throw more tokens at something, it's going better, but it's not always being worth it in any practical sense. And in our cases, actually, we care not only for solving math competitions, but for practical jobs. So also there is some kind of bottleneck, so like some ceiling, which we don't care about going above, because even it's possible, well, it's not practical in any sense. Sure.
One more question. Here, all of the benchmarks compare models in isolation. So like you run on this model, on this model, on this model, the same like benchmark. Did you stumble upon benchmarks where models were like multiple models are put in one scenario where they fight for scarce resources, or real-time like comparison of models?
So like
real-time games for models.
So there are quite a few benchmarks. Like so, just I want to like Google like that because I don't have right in mind when models play against each other. One thing which like is competition is it's like this LM Arena.
Yeah.
It's a general one that basically people compare code created by one and the other, or like images. Some people criticize this because sometimes it turns out that some models like create incorrect code, but it looks nice, so people vote for that. So it's not like very safe. There are other also arenas in which, yes, I'm human, I think so. There are some other models in which they actually compete with each other. Like, for example, various games of deception, when they try to be like Mafia, like werewolf type of games, when they try to fool each other. And it's very specific, so you can do so. But also, like it's a different kind of benchmark. Yeah. It's also interesting. Though in practice, we care mostly for software engineering, so it's usually not competition between those. At least not direct one. Okay. There's an interesting one. Like there's some interesting ones when people invest in cryptocurrencies, and there's like people joking. I know half a year ago that one model basically keeps losing money, but still claims that he's fine. He bring money back. So the people say, oh yes. He depends like an average tech guy who just got into crypto. Yeah,
and there was this Claude releasing the benchmark or whatever, the one where it steers the machine or something, the soda machine, the vending machine. Yeah.
GLM5, it's like model release. I think also they released that's the one, which is like also we saw this chart, but also this one chart is vending machine.
Yeah.
So there are various, but this kind of, I think it's not competition, but just some unknown device, and how would be able to learn from some imperfect information.
Okay. Thank you.
I'm just curious, like if there's like there was this mod book, so if there is any like benchmark saying like what's the quality of posts written by various AI agents, but I haven't seen that.
Some questions?
Hmm?
Thank
So
you.
like we'll be around like helping you with Hardboard if any other questions about benchmarks or measuring agent performance. And like if there's like if you still want to have an API key, I have a code for that. You can also use your own. For those things, it's better to use like very cheap and fast models because we don't want to spend like 1 hour for running a single task. So thank you.
Yeah.